This guide is provided as a supplement to the construction drawings prepared for your specific job. Due to the variations possible with any building, a careful study of the building's construction drawings is essential. Custom layouts, details, and parts may be required. In case of a disagreement between the guide and the construction drawings shall govern. The erection methods utilized are the responsibility of the erector of the system. Studying the construction drawings and the guide before the arrival of the steel components of the system at the job site can help enhance safety and predetermine the following cost-critical requirements: size and scheduling of the work crew, type, size, and quantity of tools and hoisting equipment needed, proper erection bracing scheme, proper scheduling of erection sequence, advanced notations on construction drawings to call out items requiring field location or modification, identification and resolution of questions. Due to continuing research and development, BEHLEN reserves the right to modify any of the details and procedures covered in the guide without notice. Erection is to be carried out by experienced, qualified erectors. Erectors must be familiar with the content of the guide and the building construction drawings. The experience, expertise, and skills of the erection crew, as well as the equipment available for handling the material, determine the quality of erection. It is emphasized that BEHLEN is a manufacturer of metal building components and is not engaged in the erection of its products. Opinions expressed by BEHLEN about erection practices are only intended to serve as a guide for erection of the system. The general contractor and/or erection of the system are solely responsible for accurate, good quality workmanship in erecting the system in accordance with the drawings and details, all applicable codes, and industry standards pertaining to proper erection, including the proper use of erection bracing and the adherence to appropriate safety programs and measures. Your construction guide is broken into 12 chapters. Chapter 1 covers the construction drawings. Chapter 2 covers packing lists. Chapter 3, the erection plan. Chapter 4 is equipment and specialized tools. Chapter 5 is unloading trucks. Chapter 6 is the pre-erection preparation. Chapter 7, the miscellaneous parts and accessories. Chapter 8, important items to maintain. Chapter 9 is the erection guidelines. And Chapter 10 is a troubleshooting guide. Prior to erecting any component, refer to the construction drawings for the building to confirm the location of that component. Improper location of components can be costly due to erection time spent disassembling and re-erecting and could result in structural failure. This section outlines some common features of the construction drawings. Note, drawings issued for approval will be clearly marked in the title block on each page. Drawings issued for construction will also be clearly marked in the title blocks. And never attempt to erect a building using drawings marked for approval. The drawing package will typically contain the following drawings: the drawing schedule, a general information sheet and conformance, the anchor bolt plan, anchor bolt details plan, building elevations, a roof and ceiling plan, sealer application drawings, ceiling connector drawings, truss drawings and details, framed opening details, ceiling access door details, gutter and downspout details, liner panel details, and any additional drawings if required. Check the drawing revisions. Always check the construction drawings to ensure that they have been issued for construction, that all drawings are included, and that they contain the latest revision available. Compare the drawings and revisions issued to the latest drawing schedule. If in doubt, contact BEHLEN Industries before proceeding. Never attempt to erect any building using drawings issued for approval. Chapter 2, Packing Lists. Construction drawing packages that are sent to site with the building include a packing list. All of the parts that are supplied as part of the building package will be listed in the packing list. The packing list is set up such that each page refers to a specific component group. There is a description of the component group at the top of the page. The typical packing list contains the following component groups: roof system, wall panels, components, nuts, bolts, sealer, framed opening components, gutters and downspouts, miscellaneous components, and liner package. Chapter 3 is the erection plan. A very early plan for erection is important. It should be as early as bidding the project. At the very least, a plan should be in place before you take delivery of your building. This plan will help you in unloading your building so that minimal amount of work is needed for labor and erection time of your core span building. Things to consider when making the plan. Number 1, condition of the foundation floor and the job site. Number 2 is the reach and capacity of your crane. Number 3, decide which end you will start erecting the building. Number 4, your equipment. Number 5, seasonal weather conditions are also important for staging material. Number 6, amount of labor available. And number 7, other subcontractors working on the same location should be considered in your plans. Under equipment, number 1, a crane is the most common piece of equipment for raising the building components. It can also be used for unloading the trucks. Number 2, a forklift can be used for moving material to and from a staging area and can also be used for unloading the trucks. Number 3, a scissor lift can be used outside or inside the building, and this can be used for panel work, fall protection, or interior work. Number 4, running gear for the scaffold is appropriate when there's rough terrain on the job site. Number 5, occasionally a roof ladder may be needed. The roof of a core span building is not particularly steep. It can be navigated easily when it is clean and dry. When it is not, something similar to the roof ladder shown, simply made of rope and board, or as elaborate as parachute strap, will be needed. Number 6, a scaffold system which will support the building system and be mobile. Number 7, lifting cables for wall, ceiling, and roof panels. Number 8, spreader bar for raising pre-built trusses. Number 9, a heavy lifting rig for unloading panels from the trucks. For the listing of tools required, see page 42 and 43 in the construction guide. Chapter 5 is unloading trucks. Now that you have a plan in place, you need to start preparing to unload the trucks from BEHLEN. First step, make arrangements with BEHLEN so your crew and equipment are ready the day the trucks are scheduled to arrive. Ensure you have the right equipment available for unloading your building. One option for unloading panels is a lifting cradle, available for purchase from BEHLEN. This will unload bundles of panels of any size, making it easy to accommodate the weight capacity of your equipment. The lifting cradle can lift as much as 5 tons or as little as 5 panels. As you are unloading, check for any discrepancies or shortages, damages, and report them to your customer service rep within 48 hours. Unloading the bundles, BEHLEN loads the trucks with panel bundles staggered at the ends. This makes them easy to pick up. Protecting the panels and storage information. All the materials need to be protected from the sun, wind, and moisture. The best way to accomplish this is to store them inside another structure. When storing outside, every effort must be made to protect them without creating or trapping moisture. When covering to protect from the environment, care must be taken not to disrupt airflow that will keep materials dry. Moving and flipping bundles of panels. The best equipment for moving and flipping bundles of panels is nylon straps. Ensure the straps are rated for your requirements. They have a capacity chart attached to the strap. Chapter 6, Pre-Erection Preparation. The idea of pre-erection preparation is to complete as much of the building as possible without the expense of the equipment and manpower that it takes for the actual erection procedure. This will save you time and money. Completing the following steps on the ground will make it much quicker and easier for erection later. Number 1, ensure all tools are checked and are ready for use. Number 2, the crew should be briefed on their positions in advance of starting. A safety meeting informing them of any possible dangers should also be held before proceeding. Number 3, check the concrete for level and square. This will also include checking the anchor bolts for correct increments and straight line condition. Anchor bolt locations, diameter, and projection should be checked against the BEHLEN construction drawings supplied with the load. The design of the building does not allow for imperfections in the concrete or the anchor bolts. Looking at illustration 6.1 for an example, the erection started at point A. For ease of assembly, line A to E should be a straight line and therefore will have to rest on 2 points. If the erection started at point A, the panel would touch at point A and point B in the example shown. This will cause all points from B to D to rise above the concrete. There is not an easy solution to the problem of unlevel concrete. The seriousness of the problem is partially dependent on the degree of variance from level. In any case, unlevel concrete will cause erection problems which will increase costs and reduce the quality of the finished building. Number 4, the base channel can be put in place. You must use the sponge rubber properly and the correct base channel, alternating the laps as shown in the construction drawing. The sealer tape can also be placed on the base channel at this time. Locate the sealer tape below the holes on the corrugated lip of the outside base channel. Leave the paper on the sealer tape until ready to install wall panels to avoid debris sticking to the tape. Note, when you install the base channel, it is a good idea to install it completely around the building. This is a secondary way to check the correctness of your anchor bolts and your building size. Number 5, prepare lifting equipment for the panels. You will need something similar to the cables shown in photo 6.3. These 4 cables have chain links on the ends with a bolt through the link. The bolts are fastened to the seam line holes, ensuring the cables will not come unhooked. This is especially important in windy conditions. The same cables work well with the wall panel, though only 2 cables are required. Note, you will also need some ropes with hooks on the end for guiding the panels and trusses into place. Prepare a lifting rig for your trusses. The one shown in photo 6.4 works very well. This lifting apparatus is made from a very lightweight trussed pipe with chains hanging from the pipe. The last link has a bolt through the link that will not come loose in adverse conditions. The pipe is approximately 21 feet long, will lift up to 40 feet of truss, and can be carried by one man. Note, you will also need a rope for a tag line to guide the trusses into place. Number 6, build your trusses on the ground. It is much easier and faster to build them on the ground and raise them into place with the crane. A rented crane is not required at this stage of the project. Build the trusses in an area that is out of the way, but accessible to your crane without carrying them by hand. If trusses are built within the building area, ensure they will be gone before your building reaches that area. See photo 6.5 for an example of how to stage the trusses. All trusses can be built in advance, or some can be saved for work on a windy day. Number 7, now is also a good time to prepare anchoring systems, similar to the ones shown in photos 6.6 and 6.7. Anchoring is required to provide temporary stability for the building and requires planning prior to starting erection. Some contractors use screw-type ground anchors, which screw into the ground with an eyelet on top. A heavy and stable object can be used to anchor the building when the ground is hard or frozen. It is very important to anchor the building temporarily. Mother Nature can be unpredictable. Number 8, the openings for your doors and windows should be cut at this time. Large openings, such as overhead doors, can be assembled on the ground, with the panels attached and installed as a complete section of the wall. This can save time and money to complete this before equipment and a full work crew arrives on the job site. Number 9, end wall panels should be sorted and staged where needed. Keeping in mind, you will need only the correct panels to install at first, leaving some out. See section 9 of the erection guidelines. Number 10, choosing a scaffolding system that will function within your erection plan. Scaffold should be capable of supporting the load of the building and its components. There are many different styles of scaffold systems. Photo 6.9 shows a typical system for a small project. Photo 610 shows a scaffold system with a guardrail for the ceiling area that moves with the scaffold. Photo 611, 12, and 13 show different styles of larger systems. Regulations may dictate the type of scaffolding system due to the area of your job site. Regardless of the system being used, ensure that the supports are set at the correct height. Verify that the scaffolding system being used meets the regulations and safety standards in your area. Typically, the walk platform will be approximately 6 feet below the ceiling height, and the screw jacks will have approximately 18 inches of adjustment for raising and lowering the ceiling. The ceiling supports should be spaced between 8 feet and 10 feet apart. The length of the supports should be determined as follows. The supports should not extend more than 24 inches beyond the scaffold. The length should be 1 panel longer than the number of sections erected per move. For example, if erecting 2 panels per move, use supports equal to 3 panels in length. The orientation and amount of scaffolding used will dictate how many panels can be erected per move. Supports should be a minimum of 4x4 timber. 6x6 timber or aluminum beams should be employed for larger spans. Loads will dictate the requirement. Note, the wheels or running gear should be able to accommodate the terrain and the weight of the scaffolding that is being used. Number 11, the corner panels should be bolted onto the sidewall panel with the tie-down angle attached to the top. See photos 614 and 615. Number 12, the ceiling connectors need to be bolted to the first row of ceiling panels. Sealer can also be applied to the ceiling at this time, as per the sealer application guidelines on the construction drawings. The location where the gusset attaches to the ceiling should also be marked at this time. These locations can be found on the truss drawings in the construction drawings. Number 13, cut 2x4 blocks 4 5/8 inches long. At least 1 block will be needed for every corrugated hump that will rest above the supports at any one given time. Note, these blocks will help to maintain the increments of the ceiling panel and keep it from stretching out. They are very important to keep in place until the supports are let down to move the scaffold. It is very important not to cut corners. Place 1 block in every hump. Any material you wish to be inside the building can be moved to the front of the scaffold or under it. When the scaffolding is moved the first time, these materials will then be inside the building. Chapter 7, Miscellaneous Parts and Accessories. Number 1 is ceiling access doors. Number 2 is gutters. Number 3 is windows and doors. Number 4 is the master flash. And number 5 is a retrofit master flash. Chapter 8, Important Items to Maintain. There are 3 things that must be maintained during the construction of your building. These are the most important rules to follow. The rest of the procedures will refer to these 3 items many times. Number 1, critical increments. Number 2, straight lines. And number 3, box frame. Number 1, critical increments. The increments associated with core span can become very critical because of the nature of a progressive error. 1/8 of an inch is not much of an error, but the same error done 16 times becomes 2 inches. Core span increments are multiples of 41 inches. Part 2, straight lines. Straight lines are another critical component of a core span building. The shortest distance between 2 points is a straight line. Now, keeping this in mind, when you have something that is not straight, you've changed the measurements between the 2 points. Note, a situation involving lines that are not straight will result in a bad fit in the direct location and will create a bad fit and more problems in many other areas of the building. Item 3 is the box frame. The box frame is another important component. The core span building is built as a solid box. Even though the panels are flexible, the box frame is not. The box frame principle has no tolerance for mistakes such as concrete being out of square, not level, or incorrect anchor bolts. The concrete foundation must be correct within very small tolerances in order to build this box one component at a time. Any one of these 3 items that is not maintained will make the other 2 items go off course. Most problems won't be noticed until all 3 items have gone astray. When this happens, it will take as many panels to fix or more as it took to get off course. If your building started to go astray and it took you 60 feet of building to notice, it will take you another 60 feet to fix it. Therefore, if you maintain these 3 items with every panel installed, you will have problem-free erection. And this will also create cost-efficient erection. Chapter 9, Erection Guidelines. The first day of erection is the most important day of your project. On day 1, it is critical to achieve enough building to safely tie down. It is very difficult to safely tie down a few erected panels. Tying down a box frame is much safer from the elements, and your crew should always be prepared for all types of unexpected inclement weather. There are many different methods to erect a core span structure. Even though the following method can vary somewhat, some procedures must always be followed. The panel number being referred to in the coming section coincides with the following drawing. Picture 9.1. And here are the steps that are recommended to achieve cost-efficient and problem-free erection. Step 1. Remove the paper from the sealer tape on the base channel. Only remove enough paper to install the current panel. Raise wall panel number 1 into place. This panel will already have the corner panel, the tie-down angles, and the anchoring cables attached. Bolt the connection at the bottom and anchor the cables to pre-arranged ground anchors at about 45 degrees. It is not important to have all the bolts installed at the bottom of the sheet right away. It is important to have the correct holes bolted first. The humps and valleys should be bolted first to conform the panel to the exact shape of the base channel. This will ensure that all the bolts will fit at the bottom. Try to get the panel as close to plumb as possible. The most practical method is using a plumb bob attached to a magnet at the top of the panel. This method will tell you how plumb you are in either direction. Improper storage, etc., can lead to panels that are not always straight enough for a carpenter level. Step 2. Raise ceiling panel number 2. This panel and all ceiling panels to follow should have the trusses and lateral spacers placed on the panel before it is raised. The small convex will allow you to fold the trusses and place them on the ceiling. Have them built in advance in sections that allow one man to handle the bundle size. Attach ceiling panel number 2 to the top of wall panel number 1. The bolt sequence is found in the construction drawings. Tie down the other end to the scaffold supports and scaffolding. Place the wood blocks between the supports and the humps of the ceiling panel, as shown in photo 9.1. Step 3. Start installing end wall panels. Start with the one that attaches to the corner panel. This will give you some stability. Check your plumb bob to get walls as plumb as possible. Leave out enough panels to let the wind pass through the end of your building, though never leave out more than 2 consecutive panels. End wall panels can only be installed until the end of the first ceiling panel is reached. In the case of small buildings, during a period of no inclement weather, ceiling panels can be installed all the way across the building before the end wall panels are started. Photos 9.2, 9.3, and 9.4 show the different styles of construction. Step number 4. Check to make sure the first wall panel with the cables attached is perfectly plumb. Raise wall panel number 3, ceiling panel number 4, and then raise wall panel number 5 and ceiling panel number 6 in that order. All bolts should be tightened as you install them. The ceiling panels have a tendency to flatten out at this time. You will need to install all the blocks under the ceiling panels. To maintain the correct increment for the top of the wall, install a come-along on top of the ceiling near the wall panel, usually about 2 to 3 feet away from the wall. Ratchet straps can also be used if they are the heavy style. Another strap needs to be installed at the ceiling panel end lap location. This one can be the first bolt hole away from the lap, if there are no gussets interfering. These straps will control your ceiling increments and should be installed on every end lap of the ceiling panels and at the wall to ceiling location. The straps are not to be removed until they are needed for the next set of panels. In order to maintain a trouble-free erection, these straps cannot be eliminated for any reason. Step 5. Continue across the building with ceiling panels number 7, number 8, and number 9. When the new ceiling panel is attached at the lap connection, a straight line must be maintained with the ceiling. This can be done by getting perfect alignment with the bolt holes in the laps, having another crew member check by eyesight from a distance, attach another come-along close to the end of the panel as not to interfere with the lap. These come-alongs must be attached before the next ceiling panel is placed at the end. It is imperative to maintain these straight lines and increments as per Section 6 of the pre-erection plan. Continue installing end wall panels across the building. More anchors bolted to the end wall panel and attached to the ground will be needed as the building progresses. It is advised to anchor the building as progress is made. Note the anchoring in photo 9.5. Step number 6. The last section of the building is very similar to the first. Raise wall panel number 10 with a corner panel, tie down angles, and anchoring cables already attached. Then raise ceiling panel number 11, check all straight lines. Raise wall panel number 12 and ceiling panel number 13. Then wall panel number 14 and ceiling panel number 15. Attach the come-alongs at the proper place to maintain the increments of 41 inches per panel. Install the blocking under the ceiling. More end wall panels can be added at this time. This now completes enough of the box frame to be fairly safe from windy conditions if anchored properly. Tighten all anchor bolts in the concrete that are involved with the vertical panels that are installed. Step number 7. Attach the roof angle to the top of the end wall panels. This will make a curved connector to attach your first roof panel. See photo 9.6. Leave these bolts loose temporarily to ensure a better fit with your first roof panel. Some of these bolts will need to be reversed because of the interference with the gussets that attach to the underside of the roof panel. Step number 8. With gusset locations marked on the ceiling panels earlier, now the trusses are ready for erection. Trusses for this building were built on the ground previously, or they were placed on the ceiling panel before it was raised. Stand them up and bolt them in place. Make sure that all your gussets face the same direction. Large trusses which cannot be folded can be raised to the ceiling with a spreader bar. This is shown in photo 9.7. This very light 21-foot pipe can lift up to 40 feet of truss. Bolt the lower gussets to the ceiling in the locations that you previously marked on the ceiling panels. The lateral spacers can now be installed at the upper and lower gussets. Once the lateral spacers are connected, the lifting chains can be disconnected. The lateral spacers have a tab at each end that alternates in direction at every truss. There are 3 possible holes in the gusset that can be used to bolt the lateral spacers. They will be bolted by alternating the holes you are using from the center hole to the left and back to the center. Which half of the gusset they are located on will be denoted on the truss drawing of your construction drawings. This can be done by stepladder or by small scaffold, as shown in photo 9.8 and 9.9. The truss and lateral spacer bolts should all remain loose at this time. It is important always refer to your construction drawings for the correct location of the lateral spacers. Step number 9. To prepare for the roof panels, install the sponge rubber on top of the wall area where the roof attaches to the ceiling. The location is shown on the construction drawings. Sealer can be applied to the roof panels while they are on the ground. The location of the sealer is also shown in the construction drawings for your building. Important to note, sealer is always installed on the weather side of the holes. Roof panel number 16 can be raised with the same 4-cable lifting rig that was used on the ceiling panels. A rope is suggested to guide the panel into place. In windy conditions, 2 ropes are recommended. 4 ropes can be used in very windy conditions. See photo 910. Important. At any sign of severe panel movement with the ropes being used, it is time to stop raising panels. Attach roof panel number 16 at the top of the wall area, and then attach to the roof channel with the bolts facing up and loose. Bolts are only tightened loosely because they are temporary until the gable cover is installed. The roof panel should also be bolted to the lateral spacers. Use a weather seal washer under the bolt head at this location. All bolts through the roof should be tightened as you go. Roof panel number 17 should be raised into place. Placing both roof panels on the roof makes for a much more stable roof for the crew who are working on them. Step number 10. Install roof panels number 18 and number 19 the same manner as panels number 16 and number 17. Step number 11. Roof panels number 20 and 21 can now be installed. First, bolt the end lap at one end, then the side lap. The last end lap at the other end should be left unbolted until the last roof panel is in place. Look at the hole alignment to verify that the ceiling supports are at the correct elevation. If it is not correct, raise or lower the supports to get a good alignment at the last lap. Important, supports cannot be raised as much on the first panel in the area of the end wall. An arch will probably be formed in the ceiling to get the roof to fit in the center. When the proper height is achieved, bolt the last end lap. The truss bolts can also be tightened. The lateral spacer bolts in the ceiling location can be tightened. The lateral spacer bolts in the roof location should be left loose, only where they attach to the gusset. Step number 12. When the entire roof is complete, the leading edge of the roof panel should be bolted to the gussets with one bolt. This keeps the last truss from sagging when you lower the supports. A roof ladder, as shown in photo 911, should be used when the surface of the panels is slippery, such as when it is covered in oil, frost, rain, ice, or snow. Step number 13. When all the bolts are installed and tightened, the supports can be lowered. It is not necessary to lower the leading edge jacks, only lower the trailing jacks. This will make it much easier to return the supports to the proper height. Scaffolding can now be moved 6 feet 10 inches. This is the width of 2 panels. This will keep the supports under the last panel line that is not completed. See photo 912. The supports can be raised up to prepare for the next set. Raise the jack on the trailing side that was previously lowered. Raise this side until pressure is being placed on the last truss that was installed. Remember to put the blocks back in. Without these blocks, the corrugation of the ceiling panels will flatten. If the floor surface is level, the front jacks will always remain in the proper position. Another example of a mobile guardrail system is shown in photo 913. Step number 14. When the first set is complete, ensure all anchor bolts have been tightened where the panels are installed. Attach gutter straps on the roof in the same manner that bolts were installed on the roof panels as per the construction drawings. Step 15. Repeat steps 1 to 14. Important: keep in mind that very small errors will multiply into very large problems due to multiple panels. Every panel that is placed must be checked for straight lines and increments. Step number 16. The full end wall can be installed when the building is at least half as long as it is wide, as long as there are some openings such as doors and windows. This end wall will provide support for wind load against the side of the building. If there are no openings, one panel should be left out in the middle of the end wall. This will release any excessive uplift on the rest of the building due to wind pressure. Step number 17. The last end wall is the final wall of the box frame. The first step to complete the last end wall is to attach the ceiling to wall connector to the last ceiling panel. Next, install all the panels in order from left to right or from right to left. See photo 914. If the increments and straight lines were maintained as the building progressed, this last wall will fit very well. Important: the order of these step-by-step procedures can vary by the order of installation for each component depending on weather conditions, the size of your crew, and the availability of equipment. Section number 10. Troubleshooting Guide. The following are troubleshooting steps and methods for correcting mistakes. Lateral spacers to gusset connection. Lateral spacers are purposely made 1/8 inch less than 41 inches. This facilitates adjustments that may be required to maintain the proper increments. Because the roof tends to shrink and the ceiling tends to stretch, the method of connecting the lateral spacer to the gussets differ for each. At the roof, this connection should be left loose. If tightened, the increments will begin to shrink by 1/8 of an inch per panel. At every third seam, you will need to shim the connection with a 3/8 inch nut. This will ensure that your increment for 3 panels is 10 foot 3 inches as it should be. Once this is done, you can go back and tighten the connection. At this point, the roof system is stiff enough that the tab on the lateral spacer will bend slightly to meet the gusset. This will keep the lateral spacer from forcing the roof panel to a 40 7/8 inch increment. At the ceiling, this connection should be tightened as it is being installed. Come-alongs are used to keep the ceiling panel increments correct, and the lateral spacer will not pull the ceiling to 40 7/8 inches on its own. If a situation occurs where the ceiling has stretched beyond the 41 inch increments, the lateral spacer will now allow you to use the come-along to pull it back to 40 7/8. By doing this, you can make a 1/8 inch correction per panel, and soon you will be back to the proper increment. Checking walls for plumb. Accurately check walls for plumb. Some wall panels may have become slightly bowed from improper storage. This makes a 4-foot level very inaccurate. The best method is a transit that will move vertically, Also, a common plumb bob works very well. The most important thing about checking the walls is detecting very early if the walls are beginning to move in or out in a direction parallel to the building span. If they do move out of plumb, it is essential to detect the problem at an early stage. There are two things that can make this situation happen. One problem is the ceiling panels are being lined up improperly by a slight fraction of the hole each time. To correct this, the ceiling panels must be moved back in the opposite direction that was previously lining up wrong. It will take as many lines of ceiling panels to fix this problem as it took to get out of plumb, maybe more. The other reason for this problem is the concrete is out of square. This problem should have been discovered in the pre-erection items and will now add substantially to the erection time of the structure. Each ceiling panel will need to be shifted, and partial holes that do not line up with this type of adjustment will possibly need to be drilled. Use a unibit to drill. This will avoid making the holes too large. If the walls are out of plumb the opposite way, this means that the panel is leaning to the left or right as you are looking at the wall from the outside of the building. The bottom of the panel is bolted in a fixed position. The top can stretch and the wall seams will no longer fit and the bottom of the panel will not fit properly. This will not happen if the come-along was placed on top of the ceiling, close to the wall connection. The fix for this problem is to place this come-along on top of the ceiling and pull it back a little shorter than it should be until the wall returns to a plumb condition. Checking lines and increments. Constantly check the straight lines and increments of the building. A 100-foot tape is commonly used to check the increments of the ceiling panels at each lap location. Always measure from the start of the building. All components must be in straight line together with each other. The wall panels, ceiling panels, trusses, and roof panels should stay aligned with the anchor bolts. Adjusting supports. When adjusting supports to make the first connection in the center of the roof panel, a good fit will not always be achieved on the first roof panel in the center. This is partially due to the outdoor temperatures during erection. In warmer weather, more arch will have to be put in the ceiling to connect the top roof lap. This condition is caused by the contraction and expansion of the panels. The first ceiling panel cannot be arched very much because of the connection to the wall. Accommodating an out-of-square slab. Having an out-of-square slab will increase the time of erection. If a check of the slab is done at the time of the pre-erection plan, complications can be minimized. If the problem of an out-of-square slab is known in advance of the pre-erection plan, a couple inches out of square can be accommodated by slotting the base channel within the tolerances specified on the construction drawings and moving it before work begins. If the slab is still a little out of square after notching the base channel, the ceiling panels will have to shift at the seam line location each time a new ceiling line is installed. In a situation of the concrete not being level, this problem can be accommodated by shifting the wall panels up and down within the tolerances of the holes. Important, this solution is only effective if the problem was discovered during the pre-erection plan, and the out-of-level problem is rather small and gradual. All of these methods increase your erection time. Severe concrete problems can also degrade the quality of your building. The dogleg. The dogleg is a problem that can happen to ceiling panels. It is a situation when the ceiling is no longer in a straight line. See illustration 8.1 of a dogleg, which has become worse with each row of panels. The width of the building is no longer the same as when construction started. This makes the holes in the seam lines not line up, changes the width of the building, causes misalignment of the ceiling with the roof and the trusses. The next line of ceiling panels will continuously be put out of alignment. This situation can progress to many other problems if not caught in time or prevented from the outset of construction. The come-alongs that are used on top of the ceiling at the lap area will prevent this problem. If this step was overlooked, the come-alongs need to be used to pull the ceiling back an extra 1/8 inch per ceiling line until it is straight. The sooner a problem is spotted, the easier it will be to fix, and if it can be prevented at the beginning, it will result in a trouble-free and cost-efficient erection. Drilling and expanding holes. There may be instances when a hole will need to be drilled or expanded to get the bolts to fit well. The best method in all cases is the unibit, shown in photo 10.1. This style of drill bit will take out material from both directions in order to minimize the area needed to be covered with the washer. The unibit is also the best option to use instead of an aligning punch to increase the size of the hole. Aligning punches are best used for moving panels for a good fit, but will oblong the hole and deform the panel. If this happens, the panels will not lay flat together and maintain a good seal. Aligning layers of material. There is an area with 6 layers of material coming together in a one-hole connection. This is on top of the wall panel where the ceiling and roof panels also bolt together. This connection should be aligned with a punch or drilled to alignment after the 2 wall panels are in place. When the ceiling panels are installed, the same procedure should be used as for the wall panels. Use a punch or drill to prepare a good fit before the roof panels are installed. Do not wait until all 6 panels are in place before trying to align this hole. Use a hammer to pound down this location as the radius of the hump is increasing in this location every time another panel is added. When this radius is not maintained closely, the interior parts, such as the sidewall ceiling to wall flashing, fail to maintain a quality appearance. It will also be very difficult to bolt this connection after the last roof panels are in place. Prepare the hole every time a new layer is installed before the next panel is placed. Checking panels. Always check the panels to see if they are the proper panel for the location before moving them into place. Some panels are identical except for gauge. Precautions for installing HSS verticals. These verticals are structural tube sections with pre-drilled and tapped holes. These can be difficult to line up with the panels because of the threaded holes. The panel that installs onto the vertical first should be pre-drilled larger with a unibit. Approximately 1/2 to 5/8 inches is appropriate. This needs to be done only if another panel fits over the top of the holes that are being enlarged. This will allow an easier fit for the last panel installed on the vertical. The last panel installed is often the most prone to not fitting well. Start by bolting this panel in the middle and work in both directions. An alignment punch can be driven into the pre-threaded hole without much damage to the threads. This will minimize the error, if any. The unibit is also needed here to align the panels with the vertical. The unibit will do little to no damage to the holes that are already tapped into the vertical. The final prep for the bolt is to use a 3/8 inch tap and a T-handle to clean out the threads. When a problem arises with your building that you are unsure of, it is advisable to consult your customer service rep at BEHLEN Industries. Chapter number 11. Tips and hints for a successful building. Number 1. The normal attic insulation guide for core span projects is to use blow-in type insulation. Walking on this will degrade the R factor of the insulation. Some buildings have mechanical equipment that needs to be accessed throughout the years. The economic solution to this would be to use fiberglass bat insulation in the path to the mechanical equipment where the foot traffic will take place. The fiberglass bats will spring back in good condition. Very heavy traffic will of course also degrade fiberglass, and in such cases a raised walkway would be recommended. Number 2. When you are unloading the trucks, keep in mind that all the bundles of panels need to be flipped over. When the bundles are strapped, do it in a way as to turn the bundles over as they are unloaded. This will eliminate the need to flip everything over later and save the crew time. Number 3. After a couple of moves of the scaffold have been completed, it is a good time to move more material under the protection of the roof that has just been completed. Even painted material such as trim will stain from the elements. These items should be unpackaged and separated in order to dry out the material. A good place to do this is the new area just built with a roof over it and walls to protect it from wind, rain, and snow. Number 4. When adjusting supports on the scaffolding, keep in mind that it is very easy to let the building down into place rather than raise it up into place. Number 5. Make sure to never tighten any truss components until the last roof panel is in place and fits properly. Tightened trusses will not raise or lower. Number 6. If the pre-check of the concrete shows some dips or humps in the sidewall area, these problems can be compensated for. When the wall panel is installed in the dip or hump location, gradually raise or lower the building slightly by raising or lowering the hole alignment in the wall panel seam line. This will shift the building up or down to accommodate imperfect concrete. Compensating for out of square concrete in this manner can only be done successfully if the problem is identified in the pre-erection preparation phase of the project. Number 7. A slightly out of square slab can be corrected with the movement of the base channel. This is done by slotting the holes in the channel within the tolerances specified on the construction drawings. Anytime poor quality concrete has to be accommodated, it will cost more time and money. Early detection is a must. Number 8. For painted material that has become scratched, use touch-up paint that is included in the building package. Follow the application guidelines that accompany the touch-up paint. Number 9. When attaching the downspout to the gutter, pre-drill the holes in the downspout. Holes can also be pre-drilled in the downspout brackets where it attaches to the wall, and the downspout before they are attached to the wall. Doing so will keep the fasteners from trying to thread two materials at the same time. Number 10. It is a good idea to place some carpet remnants on top of the wood supports where they come into contact with the ceiling. This will keep the wood from leaving a mark on the ceiling. Number 11. When trusses become large, the stepladder should always stay on the back side of the truss for the protection of the crew. The crew can also use a stick with a drift pin taped to it to raise up the last lateral spacer for the crew on the stepladder, as shown in photo 11.1. Number 12. If, when the last end wall is being installed and the side walls are leaning slightly, start in the corner where the side wall is leaning into the building. For every end wall panel installed, shift the seam line up slightly in the tolerances of the holes. This will accommodate a slight leaning of the building. Number 13. Always remember to tighten the anchor bolts every night for the portion of the building erected that day. Number 14. There are times when it is necessary to cut a hole in the panels for mechanical purposes. As a general rule, a hole up to 6 inches in diameter can be cut without using a special frame or extra reinforcement. It is always prudent to check with BEHLEN before cutting holes in the panels, as there are some instances when special engineering for snow and wind loads has been applied. Number 15. Having a digital camera on the job at all times is a good idea. If you encounter some difficulties or just have questions, it may be easier to explain your problems to a BEHLEN specialist using photos. Emailing a photo can save a lot of explaining. And number 16. After the base channel has been installed, it is advisable to place the sealer while the channel is still dry and clean. Remove the paper only just before installing the panel. This will keep the sealer clean from debris. Number 17. When installing the screws in the gutter splice, place the screws in the bottom of the gutter first. This is the area that requires the best fit. And number 18. Weather seal washers are provided for the bolts used to fasten the roof panel to the lateral spacers. These washers have a rubber base. They should also be used where the hole size is damaged in the roof from aligning pins and punches. Number 19. If at any time a hole needs to be made larger than it already is, The best method is made with a tapered unibit. See photo 11.2. When a punch is used to open the hole, the material gets bent and will create an area that doesn't lay flat together. This can cause a leak in the roof. When the unibit is used, material is taken out from all directions and will allow the material to lay flat. Number 20. The unibit is also a great help when you're installing HSS verticals. These are the verticals that are of structural steel and pre-drilled with threaded holes. The holes can be enlarged on the first panel that is to be fitted to the vertical. This panel gets covered with another panel. The holes in the underneath panel can be enlarged to 1/2 inch or even larger. This will make the 3 items easier to align when installing the last panel. The holes on the top panel can also be enlarged, but only slightly. When both panels are layered onto the HSS vertical, a punch should be driven into the hole approximately in the center of the HSS. A full hole is needed in the center, and then work up and down until it is bolted completely. Driving a punch into the threaded hole will only damage the starter thread. When any bolts will not start in any of the threaded holes, use the unibit to open the panel hole to the right size and drill part of the starter thread out. Number 21. At the top of the wall panel, where the 2 panels lap together, requires attention to ensure a suitable fit. The best way to handle this is to bend the crimp of the first wall panel up before installing the next panel. After this panel is bolted in place, bend the crimp back down and line up the 2 holes by driving a punch into the hole and ream this out until it is a sufficient size. This will prepare the area for the ceiling, which also has a hole that needs to line up with the same hole. When the 2 ceiling panels are bolted in place, drive a punch into this hole to align what are now 4 layers of metal. Ream sufficiently. There are also 2 layers of roof panels that have to fit in this area. When the first roof panel is bolted in place, once again, drive a punch into this hole. It will take some force to drive the punch. Continue in this process until the last roof panel is in place. The idea is to prepare the last hole before the next panel is placed. Waiting till the end is too late to bring the radius down into normal size. Driving the punch into this hole for every layer of metal has shortened the radius of the hump in this location. Each layer of metal has a tendency to increase the size of that particular hump, making the alignment more difficult. Driving down the size of the hump will allow the interior trim to fit much better with the corrugations. Number 22. When something becomes difficult, contact BEHLEN before it gets impossible.